I've finally introduced enough different MATLAB tools so that we can start writing some more complex programs. Dividing a larger program into different parts makes development and use of the program much simpler. The subtasks in a program are usually implemented as functions. These user-defined functions work the same way as MATLAB's built-in functions like sine, cosine, and tangent. Most computer programs will perform a variety of somewhat distinct tasks in order to accomplish an overall process. An example of this is the analysis of a set of data. In order to analyze the data, you first need to import the data into MATLAB. Once the data is in MATLAB's workspace, you'll typically perform some calculations to analyze the data. You might want to smooth or filter the data, or calculate theoretical results that you want to compare with the data. Finally, it's likely that you'll want to plot the results of your data and analysis. Plotting by itself can become a fairly long string of operations. You'll want to format the plot, apply labels on the axes, customize the axes, and so on. Performing multiple tasks like these will cause programs to become longer and more complicated, which makes them harder to use and debug. Program modules are loosely defined as a set of code that performs some specific task, such as creating a plot or importing data. These modules can be developed and debugged independently and then combined relatively easily into an overall program. The easiest way to create these modules are as functions. User-defined functions operate in the same way as MATLAB's built-in functions and are created similarly to script files. However, sometimes people have a tendency to think that something new and different is going on when they create a function. So before I talk about user-defined functions, I'll review MATLAB's built-in functions and script files. The example that I'll use for my review is MATLAB's cart-to-pole command, which converts Cartesian coordinates to polar coordinates. It's one of the functions that I used when I officially introduced MATLAB's built-in functions in Chapter 3. Anyway, recall that the cart-to-pole command accepts two inputs, the x and y coordinates of a point, and returns two outputs, the location of the point in polar coordinates. All functions have to have a name. This function's name, of course, is cart-to-pole. Functions accept a list of input arguments, which are placed in a comma-separated list in parentheses after the function name. The input arguments provide the information that the function needs to do its job. The function doesn't secretly know any other information rather than what you list here, and it especially doesn't look around in the workspace for any other numbers to use in its calculations. Also, the function doesn't know or care what variable names you use in the input argument list. You can call these variables A and B, X and Y, or Joe and Bob. The function accepts a list of output arguments in square brackets. These are the only variables that the function returns to you. It doesn't add any variables to your workspace other than these. Again, the function doesn't care what these names are. They can be theta and rho, radius and angle, or any two valid variable names. There are a few things that you really need to keep in mind when using functions. These things may seem natural, but they're common sources of confusion when people start creating their own functions. First, the only information exchanged between you and the function are the variables listed as input and output arguments. If the function creates any other variables in the process of calculating the output variables, it doesn't provide them to you. The function doesn't rely on you to provide the arguments as specific variable names. Typically, the function will use different variable names than the ones you assign in the input and output argument lists. But you don't need to know what those are. The function assigns variables based on the order in which they appear in those lists, rather than the actual variable names. Finally, you generally don't need to know how the function works. You give it a list of numbers, and it gives you back a list of numbers. Now I'll talk about how the operation of the functions is different from script files, which you're probably pretty familiar with by now. To start with, functions each have their own workspace. Script files, however, use the base workspace. The base workspace is the workspace that you're using when you execute commands at the command window. That's why all the variables created in your script files automatically appear in the workspace, and any variables you put in the workspace are available for your script file to use. Since the function doesn't have access to the base workspace, you have to provide it with the numbers it needs by listing the numbers as input arguments. Likewise, the only information you get back from the function are the variables in the output argument list. The great part about this is that no other variables created by the function will accidentally overwrite any variables that are already in your workspace. Creating a function is pretty much the same as creating a script file. You still use MATLAB's editor, and the only real difference between a function file and a script file is that the first executable command in a function file must be what's called a function declaration statement. The function declaration statement identifies the file as a function rather than a common script file and lists the input and output arguments that the function will use. Part of declaring a function, of course, is providing the function with a name. The syntax of a function declaration statement is shown here. The function declaration statement must start with the word function. After the word function, the output arguments are listed within square brackets, separated by commas. If there's only one output argument, the square brackets are optional. After the list of output arguments, there's an assignment operator. Next is the name of the function. You decide what that name is. Rules about appropriate function names correspond to rules for naming variables. It should start with a letter, have no spaces, and no special characters other than underscores. After the function name, the input arguments are listed within parentheses. The variables in this list are also separated by commas. After this function declaration statement, type the commands you want the function to execute, exactly as if you were creating a script file. This statement defines the input arguments. The list of variables in the declaration statement are the only variables that the function has available to it. The list of variables in the output argument list are the only variables that we have access to after the function is executed. Any other values calculated by the function remain hidden. After you create this function, you'll save it just as you would a script file. It's good programming practice to make the file name the same as the name defined in the function declaration statement. If you do name the file differently from the name in the function declaration, execute the function by using the file name rather than this name in the declaration statement. However, making the file and function names different can be the source of a lot of easily avoidable errors. Now I'll do a quick demo of the creation of a function file. As usual, I want to organize my work. I'll make my MATLAB demos folder the current working folder by selecting it from the drop-down menu. This menu lists my most recently visited folders. Inside that folder, I'll create a folder named Chapter 8 by right-clicking in the current folder window and selecting New Folder. I'll make the Chapter 8 folder the current folder by double-clicking on it in the current folder window. Now there are a variety of ways to create the function file within this folder. All of these are pretty much identical to creation of script files, since there really isn't any difference between a script file and a function file, except that the function file has a function declaration statement. For example, I can right-click on the current folder window, select New File, and choose Function from the resulting pop-up menu. A similar result can be obtained by clicking on the New icon on the tool strip and selecting Function. MATLAB's editor opens, ready for you to type your function in. This approach results in a template being displayed where you can type your output arguments, your input arguments, and the function name. It's also got a prompt for some comments and supplies an in statement, which is nice but not actually necessary. Personally, I don't like filling out forms, so I just create the function files the same way I create script files and type my function declaration statement myself. My preferred approach for creating a file is to use the edit command at the command prompt. So I'll type edit space chap8_demo at the command prompt and press enter. The file gets created in the current folder and the usual editor window opens blissfully blank. The first thing I need to do is create a function declaration statement. The first word of any function file will be the word function. My function is only intended to demonstrate how functions work, so I'll just create some random input arguments. The input arguments are contained in square brackets, so type an open square bracket and a couple of variable names. var_1, comma, output2. Then close the square brackets. Next, I need to type an assignment operator. The function name goes after the assignment operator. It's a good idea to make the function and the name of the file the same. So I'll name my function chap8_demo. You can make these names different, but it's generally a bad idea. Really, it can only cause confusion. So if you do happen to make the function name different than the file name is used when you execute the function. Now, inside parentheses, list the input arguments. I think I'll have two inputs, in_1 and inarg2. Now close the parentheses. From here on out, just type the commands you want your function to execute. Of course, you'll probably want some comments. I'll add a fairly useless one. This is a function that does random stuff. Next, I'll do some mathematical operations. I'll create a variable named myvar, which is 2 times in_1 plus 3. So myvar equals 2 dot times in_1 plus 3 with a semicolon. Now I'll define one of my output arguments, var_1, as the product of myvar and inarg2. So var_1 equals myvar dot times inarg2 with another semicolon. Finally, I'll create the output argument output2 as 2 times myvar plus inarg2. So output2 equals 2 dot times myvar plus inarg2. I think that's all I'll do, but I do want to comment on a couple of things. The function doesn't know anything except the values for the input arguments, in_1 and inarg2. Naturally, it also knows the values of the usual predefined variables like pi, I, and j. Those are defined in any workspace that gets created. I need to define all of the arguments that are in my output argument list. If I try to return an undefined variable, MATLAB complains. I followed all my commands with semicolons, so the function itself doesn't display anything in the command window. The variable myvar gets created by the function, and it's used in calculations inside the function, but it's not in the output argument list, so it won't be defined in the command window's workspace. Now, to make sure the function's available to be executed, click on Save. But before I actually run the file, I want to make a few comments about executing function files. User-defined functions are used exactly the way MATLAB's built-in functions are used. All input arguments have to be defined before the function's executed. Your function must define all of its output variables before it can terminate. If your function tries to return an unassigned variable, you'll get an error. As with script files, MATLAB needs to be able to find your function in order to execute it. If you use the same process you use to save your script files, everything should go just fine. My usual recommendation, as with script files, is to place the functions you'll be using during a given session in the current working folder. MATLAB will always look there for functions and files. I'll execute my function from the command window. I can execute the function exactly as I would any MATLAB built-in function. I need to send some values to the function. I'm going to define them as the variables a and b. A equals 3 and b equals 2. Now send these values to the function and return the variables as out1 and out2 by typing open square bracket out1 comma out2 close square bracket equals chap8_demo, the name of the file in which the function is saved, open parentheses, a, comma, b, close parentheses. Notice that none of my argument names correspond to names that are in the function. The values are not assigned by name, they are assigned according to their order in the argument list. So the value in a will get assigned to in_1, since they're both the first variable in the input argument list, and the value of b gets assigned to in_arg2. So inside the function, in_1 is 3, and in_arg2 is 2. So my var is 2 times 3 plus 3, which is 9. var_1 is then 9 times in_arg2, or 9 times 2, which is 18. So the first output argument is 18. Finally, output 2 is 2 times 9 plus 2, which is 20. So the second output argument is 20. Now we've gotten to the end of the file, so the file stops executing, returns the output arguments, and closes its workspace. When I called the function, the first output argument was named out_1, which will be 18, and the second output argument is named out_2, which will be assigned the value of 20. Now run the function by pressing enter to see if that's actually what happens. Cool, the function works as advertised. Now I'll check the contents of the base workspace by typing who. The base workspace has only values for a, b, out1, and out2. The variables created by the function in_1, in_arg2, myvar, var_1, and output2 were all in the function's workspace. We don't have to worry about the function variables cluttering up the base workspace and overwriting variables that we might have preferred to keep. Now I want to talk a little bit about the difference between the function name and the name of the file containing the function. I'll rename the file by right-clicking on the file name in the current folder window, selecting rename, and changing the name to chap8_demo2. Now, if I try to run the function by typing my old command, I get an error. However, I can run the chap8_demo2 file by using its name in the command. It works even though the file and the function names don't agree. Having these names be different is bad, so I'm going to rename the function back to the original name. Now, notice that I followed all my commands in the function with semicolons, so the function itself isn't displaying anything. The displayed values are the result of executing the function. I'm going to remove some of the semicolons in my function and see what happens. I'll delete the semicolons after the creation of the myvar and var_1 variables. I'll save the file and rerun it. The function runs and displays the values for myvar and var_1. Then the function terminates, sends the output arguments to the workspace, which are assigned to the out1 and out2 variables. Since I didn't follow the function execution command with a semicolon, these values are displayed. If I don't want to see these values, just follow the command executing the function with a semicolon. Now, only the function displays values. Finally, I want to talk very briefly about a few topics that are useful to know, but are probably not crucial for creation and use of most functions. If you do decide to execute a script file within a function, the script file will use the function's workspace, not the base workspace. So, suppose you have a script file that you're used to running in the command window, and it puts variables in your workspace. If you decide to have a function run this script file, the variables that the script file would typically put in your workspace won't be there. They'll be put in the function's workspace, which will be closed when the function stops executing. The function stops executing if either one of two conditions are satisfied: when the end of the file is reached or when a return command is encountered. This will become more important when we get into the next chapter and start writing programs which will make decisions and perform different actions based on those decisions. Also, MATLAB's text editor might suggest that you end your function with an end statement, which is simply the word end. This is probably good programming practice, but it's not necessary. I generally don't end my functions with an end statement. That's 3 additional characters I'd have to type, and I don't want to bother with that, since I'm probably one of the laziest people in the universe. There are a couple of variables that get defined in the functions workspace when a function's called. They are nargin and nargout, and they contain the number of input-output arguments that are sent to the function. You can set up your function to do different things based on the number of arguments. That's why a lot of built-in MATLAB functions can have alternate uses, which require various numbers and types of arguments. This is another case in which I need to talk about decision making before it can really make sense. You can define variables that will be available in all workspaces so that they're available for functions to use without sending them to the function as arguments. You do this with a global command, and the resulting variables are called global variables. However, just because you can do something, it doesn't mean that you should do it. If you decide to make a variable global, you need to have a really, really, really good reason for doing that. That's because if you make a variable global, you need to make sure that the same variable isn't defined somewhere else with a different value, because the global value will redefine the variable everywhere. If you've forgotten that another function uses that variable, you can get a very nasty surprise. Because of this, I'd suggest that you never use the global command unless you're directed to by your boss or a team leader. A global variable essentially eliminates one of the best features of functions, the isolation of various workspaces from one another. That's about all there is to functions. Now, I've found that some people resist using them at first, since it seems like more work to have to define input and output arguments. However, the effort more than pays off in the long run. Your programs can become more modular, and you don't have to work as hard to make sure you aren't accidentally overwriting an existing variable. Plus, it becomes much easier to do tasks that are repetitive or commonly done. The advantage will become more obvious when I talk about decision making and looping structures in the next couple of chapters. Decision making will be the topic of the next couple of videos.